This video is the second part to our intro to graph by transformation. In the first part of the video, we learned to identify the transformations and how to perform each one individually. In this part, we're going to learn how to put the transformations together into a larger problem. We're going to be performing multiple transformations on a parent function, but these transformations have to be done in a particular order. The order to perform transformations is first, you want to apply any horizontal shift. Second, a reflection about the x-axis. Third, horizontal expansion or contraction. And you'll notice that these first three are all horizontal effects. And horizontal transformations are always identified by something happening inside the function. So think about it. We're following order of operations here. With order of operations, you always start inside the parentheses or inside the absolute value, and that's just what we're doing here. So we're going to do the three horizontal transformations first, but you have to follow this order. Then we're going to move outside the function and do the three vertical transformations: reflection about the x-axis, a vertical expansion or contraction, and lastly, a vertical shift. If you do not go in the proper order, you will not get the correct graph in the end. So it's really important that you study to remember these 6 transformations in order. As I've mentioned several times in part 1 and also this video, all transformations occurring inside the function have a horizontal effect on the function, while all transformations occurring outside the function have a vertical effect on the function. We want to graph y equals -2 times -x plus 4 squared minus 3. Clearly, this is more involved than what we saw in part 1. There are multiple transformations occurring. Well, the first thing you want to do is get organized. Anytime when you have a more involved math problem, it's so important to set out a plan. So our plan starts with identifying what the parent function would be. The parent function is always x, and then whatever big operation is happening, whether it's a radical, an absolute value, a fraction, or an exponent. In this example, it's an exponent. So our parent function is going to be y equals x squared. So we start with that. Now we want to start looking at this equation, this long equation, and start looking for transformations in the particular order outlined for us. So the first thing we're doing is looking for a horizontal shift. We recognize a horizontal shift by having either plus or minus a number inside the function. Well, we have plus 4 inside the function. So that plus 4 tells me shift it to the left 4 units. What I'm doing here on the side is as I'm listing out my plan is we're always building off the last equation we were working on. So I had my parent function y equals x squared, and now I'm building off of that and I'm adding the plus 4 on the inside and denoting that that means shift it to the left 4. I strongly recommend colored pencils when working on graph by transformations. As you can see it with my picture there to the right, we're going to have many graphs on one piece of graph paper. If you're just using a regular pencil for everything, it's all kind of going to blur together. So I strongly recommend colored pencils, and we will coordinate the color of our equation with the color of our graph. All right, so we shifted left 4 plus 4 on the inside. The next transformation we're looking for is a reflection about the y-axis. That's our horizontal reflection. We recognize a horizontal reflection by having multiplication by a negative inside the function. If you look at our original problem here, we do indeed have that multiplication by a negative inside the function. That tells us we will have a horizontal reflection. So now I'm building off my last equation, which was my yellow one. I'm going to take that yellow equation and then simply add that negative in front of the x and denote that this is a reflection about the y-axis. You could be more detailed at this point if you wanted, just to help yourself, and put down that we are going to multiply all of the x values by -1. And that'll get us our reflection. The next transformation we're looking for is a horizontal expansion or contraction. We recognize that there's a horizontal expansion or contraction when you have multiplication by a number inside the function right in front of the x. So if you take a look at that original equation, is there a number other than 1 right in front of the x? There's not. Now you may be thinking, yes, there's a -1, but we already handled the negative. That was the reflection. And we're looking for a number other than 1 in front of the x. We don't have one, therefore there is no horizontal expansion or contraction in this example. Moving on to our fourth transformation that we're looking for. We're looking for a reflection about the x-axis. A reflection about the x-axis is identified by having multiplication by a negative outside the function. And if you take a look at our equation, we do indeed have multiplication by a negative outside the function. So now we're building off of the red equation. Right? We're adding to the red equation to get the blue equation a negative on the outside. And we're denoting that this creates a reflection about the x-axis. I'm going to further note that to get the correct points for that reflection, I need to multiply all of the y values by -1. The next transformation we're looking for is a vertical expansion or contraction. We recognize that there is going to be a vertical expansion or contraction when we have multiplication by a number other than 1 outside of the function. So taking a look, do we have a number outside of the function that's multiplying? Yes, we do. This 2 right here. Again, we're ignoring the negative because that was the reflection. I'm building off my blue equation to get the purple equation. I'm adding to the blue equation the number multiplication by 2 out in front and denoting that we're going to have a vertical expansion by 2. We could further add that we are going to multiply all of the y values by 2 to get that vertical expansion. And then last but not least, we're looking for a vertical shift. We recognize that there is a vertical shift when we have plus or minus a number outside of the function. We see this -3 outside the function. That tells us we have a vertical shift down 3. So I'm building off my last equation. From the purple equation, now I'm going to add that -3 on the outside, and that is going to give me my final equation there in green. You'll notice that I highlighted that original equation a whole bunch, but I like to do that to make sure that I've accounted for everything. Notice the only thing that isn't highlighted is the x and the squared, which was the parent function in the first place. That should always happen. The only thing that shouldn't be accounted for is the parent function. Now that we have a plan, It's time to execute the plan. We start by graphing the parent function. And you'll notice I'm using the same colors, black equation, black graph. So we start with our parent function. I really recommend that you write out points for this. My students that are most successful write out all the ordered pairs for each of the graphs. So I'm going to do that here down below. The points for the parent function: -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And now I'm ready to perform my first transformation. My first transformation is a shift to the left 4. Now, that's a horizontal shift. So think about whether it's going to be the X or the Y coordinate that is going to change when we have a horizontal transformation. Well, it's going to be the horizontal component, which is the X. And since we're moving to the left, on the X-axis, further to the left is our smaller numbers. So we are going to decrease all of our X values by 4. So basically subtract X from 4 from all of our X values. I don't have a yellow pen, so I'm going to highlight it here in yellow. So subtracting 4 from all of our X values, we get -6, 4, -5, 1, -4, 0, -3, 1, and -2, 4. Now that we have these ordered pairs, we want to plot them and draw in our graph. Plotting our points. And then drawing in our graph. There in yellow, we have the graph of y equals x plus 4 squared. Next, we have a reflection about the y-axis. We've already noted that we want to multiply the x values by -1 to get the correct points for this next graph. And we're always building off the last. So now we're building off of our last set of points. And we're multiplying all those yellow points, all the x values, by -1. These will give us our red points. It's going to be 6, 4, 5, 1, 4, 0, 3, 1, and 2, 4. We have our 5 points. Let's graph them. And then we draw in our graph. And you'll see that our yellow graph has been reflected about the y-axis. So everything that was on the left is now on the right. At this point, we want to transform that red graph by reflecting it about the x-axis. To get the correct points, we're going to multiply all the red points, all the y values in the red points by -1. Gives us 6, -4, 5, -1, 4, 0, 3, -1, and 2, 4. -4. We're going to plot those points. And draw in our blue graph. You'll see that our red graph has been reflected about the x-axis and given us our blue graph. So that blue graph is the graph of the equation y equals negative x plus 4 squared. Blue graph corresponds to the blue equation. We're not done yet, though. Our final answer is until we get to our green equation. So we got 2 more moves to go. Now we want to take that blue graph and vertically expand it by 2. We're going to multiply all the blue points, all the y values, by 2. Multiplying our blue y values by 2, we get 6 negative 8, 5 negative 2, 4 0, 3 negative 2, and 2 negative 8. We'll plot these 5 points, draw in our next graph. And there we have our purple graph. We see that the blue graph has been vertically expanded by 2. We're almost done. Last one. Now we want to take the purple and shift it down 3 units. So I'll turn my attention to the points. If we're shifting down 3 units, down is a vertical shift. So we need to change the vertical component, which would be the y values. And since we're going down, we know that y values get smaller as we go down. So we'll be subtracting 3 from each of the purple y values. 6 negative 11, 5 negative 5, 4 negative 3, 3 negative 5, and 2 negative 8. Plotting these points. And connecting them. We are now at our final answer. There in green, we have the graph of y equals negative 2 times the quantity negative x plus 4 squared minus 3. All those other moves are a means to the end. If the directions say graph by transformation, I need to see the transformations. I either need to see the multiple graphs on the graph paper, or if that is too cluttered for you, I need to see all the different sets of points and then the graph of just the final graph. But in order for you to get credit for graph by transformations, you got to do the transformation.